Hello friends, welcome to Biology lectures. I am Ritam. Today we are going to discuss the lac operon. So let me write lac. Here I have written all the topics on which we are going to discuss. So let me discuss what we are going to do. Why microorganisms use lac operon? What is the manner of lac operon synthesis? Components of lac operon system, lactose and lactose. When lactose concentration is high and when lactose concentration is low, then what scenario we can find there? Structural gene synthesis and enzyme production. We will show lactose synthesis or lac operon inhibition mechanism and turning on and off of lactose operon when lactose concentration is high. So let me start. Actually, lactose or operon are of three types. Operon are basically of three types: lac, trip, and their full form is lactose, tryptophan, and arabidose. In our syllabus, only lactose operon is there, so we are going to discuss this only. And trip and ara are in higher studies BSc. So let me copy it. The main question arrives: why a microorganism use lac operon? Here I have written why lactose. Because we all know glucose is the simplest source which microorganism catabolize to get energy in the form of what? ATP, adenosine triphosphate, or GTP, guanosine triphosphate. So why lactose? It's basically the easiest path they will follow. Why they have taken lac operon, or why they use lac operon system? Now let's imagine a scenario. Suppose glucose concentration is lower, okay, and bacteria has no, or microorganism has no energy source to catabolize. So then what they do? They will uptake lactose and catabolize them in the form of glucose plus galactose. Who catabolize it? What are the enzymes? We will talk it later. In here, I have written over here. So this glucose go and make this down concentration up, and so ultimately this cycle go on, and it can able to produce energy out of this lactose. Okay, complete. Let me discuss in what manner lac here. Also, we have completed this topic. Why lactose operon is used. So in next number 2 topic. Number 2, what is the manner of lac operon synthesis? Lac operon synthesis is done. This is a mRNA strand, mRNA, messenger RNA strand, mRNA strand, where this is the whole mRNA strand. And this part is basically the lac operon part, where the ultimate scenario is going on. In lac operon there is a promoter. Let me use the marker. Promoter, P sequence, and there are several structural genes. We will make it detailed view in the next lectures are coming. Structural genes. Which ultimately catabolize lactose here. So after P, there is an origin site. Okay, and in origin, these are lac Z, lac Y, lac A. These are the structural genes which ultimately catabolize lactose. So, who catabolize? It's the main question. RNA polymerase. You know, RNA polymerase is the sole thing which ultimately, this is mRNA and suppose this is RNA polymerase, and it will move like this so that operon can be synthesized. So, what is manner in lactose or lac operon synthesized polycistronic manner. Polycistronic manner. So what is polycistronic? Poly means, you know, many. That basically one RNA polymerase, suppose this is RNA polymerase. This come and bind to promoter and operator sequence, and this promoter basically a signal for these three genes. It will catabolize this, and this. So this is polycistronic, many, 1, 2, 3, many, and cistronic. The gene production. As these are the structural genes. So under one promoter, multiple genes can be transcribed. This is known as polycistronic. So this is the manner in which lactose operon synthesis goes on. So this the topic 2 is completed. In third, we are going to discuss what are the components of lac operon. This is lac operon. This is the promoter sequence. This is the origin sequence. As I have drawn it earlier, lac Z sequence, lac Y sequence, lac A sequence. This is the main scenario. This is the lac operon, and here there is I, inhibitor. Inhibitor means which inhibit the synthesis of lac operon, and PI, promoter for this inhibitor, which start the inhibition. This promoter start the inhibition. This is the scenario. So this is promoter, this is operator, structural genes, inhibitor, promoter for inhibitor. Okay. So in this lecture we have completed three basic things which you should have to understand before starting lac operon. All the mechanisms, these 4 mechanisms, these 4 scenarios which we are going to discuss in the next lecture. So for today, or for this lecture, up to this, it's over, and we are coming on next lecture. Keep learning. Best of luck.